Hey, sixth grade, welcome to chapter 2. The big question we're trying to answer in chapter 2 are how do rocks form? And since rocks are defined as mineral mixtures, chapter 2 starts with figuring out what minerals are. So when we're talking about minerals, we're going to start by trying to define some characteristics of a mineral. Now, a characteristic is a way to describe something. So we talk about characteristics an awful lot in science. What is the characteristics of certain organisms, or what are the characteristics of the mantle, what are the characteristics of Earth's crust. After chapter 1, you can already tell me some of those things, and that just basically means, can you describe those things? Can you use observations to describe them? So minerals have very defining characteristics, and if you come across a sample of something and you're not sure whether or not it is a mineral, following these 5 guidelines, these 5 characteristics, will help you determine if your structure, if your sample is a mineral. So first and foremost, may seem kind of obvious, but minerals are formed by nature. So there are processes in nature like changes to heat and pressure in the Earth's crust, distance from a magma source, that define how minerals occur and what minerals are formed. So naturally occurring means that it's not a mineral if we make it. Now, I'm saying that because we do actually have the technology to make synthetic minerals right now. We can make synthetic diamonds, we can make synthetic emeralds by adding just intense heat and pressure in a lab. But if we're talking about minerals, real minerals, there has to be something in nature that causes them to form. And you learned in the last chapter that the things we're talking about when we're talking about the structure of the Earth are basically changes in heat and pressure. Seems fairly obvious, but the second characteristic is it's inorganic, which basically means it's not made of anything living. Now, this may seem like a crazy thing to say, but the reality is it doesn't have living things in it, or I should say once living things in it. Because when we talk about rocks, when we talk about sedimentary rocks, there's an entire category of sedimentary rocks that are fossils, that are fossilized into rocks. But if you have a mineral, there is nothing that is organic about it. It is all non-living, inorganic material. It's also formed by inorganic processes, meaning that the heat and pressure from the Earth are processes that form them, and they are not formed from living things like fossils. Obviously, third one's easy. Not going to take time on this. They're solid. They are not in liquid form, and so as you're trying to determine whether or not you have a mineral, if it's a liquid, it's not a mineral. Crystal structure. So thanks to Harper, we might be growing some crystals this week, but minerals do have a very defining crystal structure. And basically, the chemistry behind crystal structure is that the particles, the atoms that make up the mineral, they are very organized in specific geometric patterns. That's what a crystal is. Everything is made of matter, and all matter is made up of atoms. How that matter is organized determines whether or not it's a crystal. And so if that matter is organized in a very pattern-like geometric structure, you have yourself a crystal. So some of what we might be doing this week is growing crystals out of sugar. Sugar is a crystal, does have a crystal form, and we can use this to grow more crystals. And when we look at them under a microscope, you're going to see that they have just a very flat-sided geometric pattern. Definite chemical composition. That means that all of the elements that make up specific elements, they come in very specific ratios. And I use a basic ratio. Water is not an element. It's not a mineral, but it has a specific ratio. Water, you know, is H2O. That's a ratio. For every 1 oxygen, there are 2 hydrogens, H2O. So 2 hydrogens, 1 oxygen. That ratio would be 2 to 1. So minerals are made up of elements. in very specific ratios. So you might have quartz contains 1 silicon, so it's silicon dioxide. So it's 1 silicon to 2 oxygen. So if you have 1 silicon and 2 oxygen, you have quartz. That's a very definite chemical composition. If you threw in an extra silicon or threw in an extra oxygen, you would not have quartz. Okay, so we'll talk about more of this tomorrow, but just kind of keep this in mind. I do think that might be too late now, but you should be taking some notes with this. I didn't give you notes because tomorrow we're going to do an in-class Kahoot quiz, but there's a lot of details in this lecture, so some notes might help. So now that we know the characteristics, we're going to talk about how to identify them. So if you come across something and it's you've determined it's naturally occurring, it's definitely a solid, it's inorganic, you've determined that it's got a crystal structure, and maybe you're fairly certain it has a definite chemical composition. Now you want to know what it is. What do I got? I know it's a mineral, but there are many, many minerals. Which one do I have? And so there are there are very specific ways to identify them. And this whole week and into next week, you're going to be given a mineral kit and some of these tools to identify them. In your mineral kit, you won't know what minerals you have, and you will have to use these identification tools to try to identify them. I won't get through all of them today. This video is really not going to go longer than 10 minutes. I'll probably get through a few, and then we'll have another video tomorrow with the rest. But the first way to identify a mineral is just by looking at it. We make observations of everything we see, and so when you look at it, it has a color. Okay? Now, color's great. It can be very helpful, but it's not exactly the best identification tool. And I put a picture up here of gold and pyrite because you've heard of fool's gold. Pyrite is a mineral that's called fool's gold because it, by color, looks just like gold. Now, why we don't want to use color is that there are things in nature that can alter the look of a mineral. They can affect its color. They can change it. They can make it impure. And color is the first thing that's affected by that. Something in nature is not going to change the chemical composition. Something in nature is not going to change the crystal structure. But something in nature can change the color. And so while it might be a good place to start, it shouldn't be where you end. You shouldn't say, oh, that looks like it's transparent, it's got to be calcite. You want to go further, okay? So start with color, but understand that it's not the best form of identification. Next, whoa, so back there, one more. Luster. Tomorrow we'll definitely look at luster. So luster is how shiny something is. It's the scientific word for shiny. So luster is how light is reflected off of the surface. And minerals that have a kind of high luster are considered metallic. And you can think about something metallic, kind of understand, or maybe take out a piece of aluminum foil and put it up to the light and watch how the light sort of reflects off of that. So if light reflects off of the surface, that has a metallic luster. If it doesn't, it can have anything from metallic to pearly. It can also have earthy. You could be looking at a mineral that really, really looks like a rock. It can have an earthy luster, meaning it's not shiny. It doesn't reflect a lot of light. You can feel some minerals and they'll feel waxy and greasy. That's also luster. So when you're looking at a mineral, you might look at its color, and then you want to look to see how much light it reflects. Not all minerals are metallic, but it is a good way to kind of categorize what you have. I've looked at it, I know its color, and now I want to look at it and I want to see if it's waxy, greasy, silky, metallic, or earthy. So I'm going to pause right now because I am almost out of battery and I'm just going to change my location. Okay, I'm back. Sorry, the light might be a little weird on this one. Okay, so we ended with luster. So now we have color and we have luster. Let's see what's next. Streak. So tomorrow you're going to get some minerals and you're going to get a porcelain plate. And streak is the color of the powder that is left when you scratch the mineral along this plate. And now this is a very interesting test to do because you might be looking at a mineral that is a certain color, but the powder that it leaves is different. And that's a very defining identification for a mineral. The streak is a really good factor to consider when trying to identify the type of mineral that you have. This is the thing that makes the color that you saw, if there are impurities, impurities do not affect the streak. They only affect the color. And so you might have a mineral that looks a certain color, and then you'll do a streak test, and the streak test is completely different. And pyrite, I'm not going to give it away, but pyrite, when you do a streak test, looks very different than the color of pyrite in your kit. So streak test will help confirm what you saw when you first looked at the color. I think I'm going to end there. Tomorrow we'll do a video on hardness, and cleavage and fracture, and then how minerals form. So remember, you might want to take a few minutes to review this video again, and then tomorrow, know when you come in, there'll be a Kahoot ready to go, and I'm going to be looking at the final results of that to see how well we're doing with this. Thank you, and I'll see you tomorrow morning.